All right, so here we're gonna take a look at where does DeMoivre's theorem come from. And DeMoivre's theorem says if we have a complex number in trig form, and this is one reason why we need to be able to write complex numbers in trig form, is because if we have a complex number raised to any power n, what is that equivalent to? It's equivalent to r to the n times the cosine of n theta plus I sine n theta. But why does that work that way? Well, let's start by considering r cosine theta plus I sine theta to the second power. N is 2. Well, if n is 2, then we know if we have r cosine theta plus I sine theta multiplied twice, cosine theta, I sine theta. All right, well, we learned earlier that multiplying two complex numbers in trig form, we learned that this is equal to r squared times cosine 2 theta plus I sine 2 theta. All right, good enough. So we learned that. Well, let's consider r cubed. Well, r cubed we can think of as r squared times r. Well, this is just r. I'm sorry, not r cubed. We're looking at our, if we have another complex number cubed, then that's the same thing as this. This is our complex number squared times our complex number. So we're just doing an extension of this situation. Well, this is r cubed times the cosine. We add these, we get cosine 3 theta plus I sine 3 theta. And you could keep going and going and going. But in general, what's going to happen is when you have, so this expression here is equivalent to r cosine theta plus I sine theta cubed, right? And we see it's equal to this. And if you just kind of keep going and extend the process, we end up with r to the n. When you take a trig form complex number to the n, we just end up with r to the n, r to the 3 in this case, and then our argument theta is multiplied by the exponent, and that's where the n theta comes from, and the two cosine and sine terms. And that just kind of shows, it's a little illustration of where that formula comes from. So in the next video, we'll actually do an example of using this DeMoivre's theorem.